Hey, so, all right, we were just chatting before about Flash technologies and what have you, and I thought, well, hey, great opportunity. Let's talk Flash. I mean, Flash, we're seeing a lot more of it these days. A lot of EMC products, obviously. A lot of our competitors. It's all about Flash. A lot of small startups coming through as well with just Flash-based storage. So, what are you seeing in this space at the moment?
It's a bounty of Flash that we're seeing in this space at the moment, and it's Flash. The idea was that it was going to be everywhere, and it is indeed going everywhere, right? So it is in the server, in the network, and in the end storage array. And the interesting thing about Flash is that it's really like CPU performance. It allows you to get more work done by being more responsive, so you get more work done. You know, for specific workloads, the addition of Flash, because of this asymmetrical characteristic that it actually has, the ability, the read latency being marvelous in comparison to write. For read-intensive workloads, you can actually get a heck of a lot more work done.
Yeah, so you're seeing sort of like more uptake of, when people are going out to perhaps, refresh their existing storage, people... obviously looking at Flash as an option. Are we seeing sort of like a higher uptake with, Flash-based drives now?
There is. What we're seeing inside EMC is that for the most part, systems that offer it, if we're not hitting towards 50% or haven't hit it already, nearly everything heading out the door today is actually doing that. So that's the interesting part of this. You're seeing people, they're taking it, they're using it in different ways. The easiest way to consume it for people of existing storage is in the disk format, the disk packaging, the solid state disk packaging. But that isn't the only way that Flash is going to be accepted. The thing about SSDs, and people say you don't get the value, you don't get this. The failure characteristics are known, right? You know how to react to a failure of that device. What we've seen going forward as people adopt it as maybe as form of an extended memory tier is they actually we've worked out how to actually adopt Flash and how it fails and how to manage that when it does fail in your environment.
Well, that sounds good, because the way I've had it described to me, obviously the drives that go, Flash drives that go out, they do have sort of like some resilience built into them, in as much that, for example, you may buy a 400 gig drive, while the actual Flash on there maybe, for example, 450 or 500 gigs, and you've got that resilience built in for if and when there's some failure there.
And it is not just that, right? It isn't just that. It's also in the system software and how the system software itself handles a failure, right? And that's what it comes down to. It's used to a disk or a device going away, right? So it's the case, how do you actually handle a failure, not just blocks being allocated inside but a failure inside the entire device. And typically with stuff like RAID technology and stuff like that, we know how to handle disks going away. But so that was the easiest and quickest way to actually consume it going forward. But now what we're finding is that the whole card thing, right, using it as a cache in different places. We have the technology for that, and now there's the aspect of moving it towards a memory tier. And if we look at this stuff going forward, where do I think it's going to go? Well, it's main memory as storage. If the economics might not be there with Flash at the moment, chances are they never will be there, right, with Flash at the moment. But what about when we move to phase change memory? We move to these main memory systems as your primary storage. We're going to have to change our programming paradigm, how we develop software, and how we actually do caching inside our applications, how we actually cache stuff in various places inside memory, inside storage. And it's going to be over the next probably couple of years, next 5 to 7 years, towards the end of this decade, it's going to be a really, really big deal. I think there's an awful lot of innovation coming.
So, Flash, we're really at the start of the journey with Flash and inside storage, and other devices at the moment. Obviously, prices are dropping as well, which makes it more attractive for wider adoption. And I guess one question we've got, are you seeing any particular use case for the use of Flash or applications, for example? Are people tend to just using them for like tier 1 applications at the moment, or are we seeing sort of more wider use cases?
Tier 1 applications are always a big thing. Financial, high-performance financial transactions, all things like that. Anything which requires a massive read latency. Capacity-wise, it doesn't make sense for a lot of things. Now, people are introducing deduplication, they have compression, they have all these things, making all these interesting claims that have yet to be proven out. This is like the whole tape thing, right? Whereupon, yes, price per gig of a tape drive or tape cartridge is cheaper than a disk drive, and same thing is going to continue for flash drives. And we're actually seeing the hard drive manufacturers moving towards their own standards organizations. Now, it is a duopoly at the moment, but they're kind of like doing like what tape drive manufacturers did with the LTO, the Linear Tape Open Consortium. Now you have like hard drive consortiums, right, of people. They really are circling the wagons and looking to make the capacity play going forward. So I think that's where they see their future. The concept of what we knew it as, the fiber channel drive, is going away, if not gone, right? So that high performance disk drive is going away, if not already gone. But flashes, it's all the need for speed. That's pretty much what it comes down to.
So we're going to see sort of like, the existing or the more traditional type storage devices, like, we're seeing at the moment with the, EMC's range, for example. Mm-hmm. But you've got a mixture of SAS-based drives with flash in there, obviously serving two, dual purposes. So you don't foresee that going away anytime soon. I imagine that's going to be around for quite a while yet.
It's going to be around for quite a while, simply because the economics don't work, right? So the economics don't work to get rid of these things, regardless of what the startups are saying. We're just creating too much information. There's a new thing it's not new, it's old, but I'd like to bring it back. It's called deletion, right? So deletion, no one deletes anything anymore, right? Prices have come down so cheap, you're buying external hard drives. I mean, you go off, you buy something somewhere. We're talking about cloud storage now, whereupon it takes weeks to upload and then months to bring back, or some ridiculous concept like that. And that just isn't going to go away. I do believe that, and we're seeing it right now. Everyone's laptop, everyone's, like, if you have an iPad or you have a phone or something like that, that is flash already. But we're moving to the more discrete, lower capacity devices are going to move all flash, and you're still going to have the great big honking disk in the back for a while to come yet.
So one subject you touched on there was deduplication. I mean, one product I've seen in the EMC's portfolio now, it's quite a new addition, is the Extreme IO. I mean, that does some pretty cool stuff around deduplication on storage. So, do you want to just take us through, what that offers and some of the benefits that this new product brings?
Well, data deduplication, if you actually consider it with a flash device, you want it to dedupe because you want to minimize the amount of write cycles you actually make the device in the first place. So it makes sense. Inside the operating system, I will get the name wrong. I promise you I will get the name wrong. Xios, right, is the name of the Extreme IO operating system. Now, it's no doubt pronounced completely differently, but that's how I read it. That does 4K block-level data deduplication, and it's managed to keep the entire namespace inside RAM, which means it can do it incredibly quickly. So it can provide 4K block-level data deduplication very, very quickly throughout the entire Extreme IO scale-out cluster. Project X, right? If you're in marketing, you call it Project X. And what that actually does, not only is it a capacity thing, but it actually reduces the amount of writes you have to make to individual flash cells. So when we're talking about over-provisioning, which is what you were discussing earlier on, that actually can extend the life of these flash devices. So useful not only from a storage capacity point of view, but also from the fact of write endurance, keeping these individual modules there and available and running.
That's fantastic. And you mentioned the scale out there. I mean, that's another great feature with Extreme IO. That's something we see with Isilon as well. Yep. That's one of the definite selling points of that. So I mean, that's brilliant. I mean, the fact that you can actually scale it out as and when needed, definitely a benefit there with it as well.
And you consider these devices that scale out, they do remind me, technically not accurate, but they're giant InfiniBand SANs, really. Or maybe not giant, they're just InfiniBand storage area networks. So when people who say the storage area network is dead, a lot of them are building storage area networks inside these appliances, which they're actually they're delivering to you a storage system. So you mentioned Isilon, you mentioned Extreme IO, there are a couple of other competitors out there. They're doing it, they're gluing things together with InfiniBand. There's traffic heading around through the back interfaces, scale out, auto rebalancing, all the good stuff, right? All the good stuff that's really going on there. And we talk about scale out. Scale out isn't really incredibly new. I mean, like the whole thing you can talk about, you could say that Symmetrix, an EMC Symmetrix was a scale-up device, but you look at the VMAX, it's rapid I/O backplane in there, you add extra devices. So EMC was doing scale-out with like VMAX, right, and stuff like that. But now we have a very strong portfolio in block storage. You have your incredibly high performance block storage with Extreme IO. You have the platinum service level and availability with VMAX, and you have Isilon, your large scale of massive file system, does HDFS and whatever else they plan to add on in there, and I know stuff they plan on adding on in there later on. So scale out, interesting and exciting.
So we're looking at an interesting future around these technologies, obviously. So
yeah, if I look at the particular segment that I'm in, right, which is in the storage space, the particular segment that I'm in, if you look at servers, you look at networking, those are, they might argue with you, especially with the open flow stuff and the software-defined networking now kicking off, Nicira and VMware. But I still think in storage, it's just like every day, something new every day, right? You look at the server space, you look at there's nothing going on there. It is dead, right? It's moribund. Their big thing there is using ARM CPUs, maybe low-power ARM CPUs. This is their big revolution. Networking, until software-defined networking, nothing much going on, but every day with storage, something new. There's always a new startup. They always have something interesting there, and you really have to look and see whether or not this is actually going to change something. This is actually going to make a difference, or is it yet another flash in the pan? And there's been so many flash in the pans. There's always a crop of storage startup failures, which I love the fact that there's such heavy investment in storage startups. Some of them will be in every generation of storage startups. You have the winners. Some go on. Not many. If we look at the last company to actually break through that wall of fire was NetApp, that so long ago actually became a multi-billion-dollar company. Everything else from then, who has been a winner, has been acquisition bait. But by pumping that acquisition money into the market, you accelerate VCs, venture capitalists, very interesting because they're looking for their exit. And we've an awful lot going on in every space. If there's a gap, there's a startup there to fill it. And it's up for the rest of us, customers, vendors, the whole thing, to actually figure out whether or not this is, it's real, whether or not the market is real, whether or not the technology is important, or it's just the bit of hype this week, which is replaced by a bit of hype next week.
Well, Zilla, fantastic, interesting stuff, and definitely, a very exciting future, especially around the flash and storage space. So, thank you very much. So, if people want to, find you on Twitter or your blog there, how do they get hold of you?
At StorageZilla on Twitter and storagezilla.typepad.com, because I'm too bloody lazy to buy a URL online.
Thanks very much.
Thanks, Simon.